In this video, I'm going to work through a slightly more sophisticated example that I have shown here. So in this example, we have a circle, and we can adjust the position of this circle. So we can move the circle around the graphics view. We've got a point that controls the radius of the circle. And like we've seen previously, I've got a point on the circle that's going to adjust the openness of an angle that I have shown here. Now I have two vectors, this red vector representing the sine value of this angle's measure, and a blue horizontal vector representing, in some ways, the cosine of the measure of this angle. Now there's a lot of mathematical details you might add into this, but this is essentially what we have. And also I've got some tick marks along the edge of this circle, and each tick mark along this edge represents 1 radian. So right now this angle has a measure of 1 radian, 2 radians, and so on. Okay, let's get started. Let's start by creating the center of the circle. So I'm going to do a free point. We'll just do O equals 1, 1. And really I'm just placing a point in the graphics view to use as the center of our circle. And next what we're going to do is actually create the point that controls the radius of this circle. Now this is a little sophisticated, but I'm going to do RP for radius point equals point. I'm going to put a point on a ray that starts at O and then extends from O to O plus 0, negative 1. And if we break this down a little bit, the ray that starts at O and passes through O plus 0, negative 1 is really just a vertical ray. It starts at O and goes directly downwards. And really we just want to put a point on that ray. So I'll hit enter. And now what we see is as I adjust O, this point RP always stays on this ray that starts at O and just goes directly downwards. So what we'll do is do R equals Y of O minus Y of RP to get the distance between these 2 points, which will give us the radius of our circle. Okay, so now we'll actually create the circle. We'll do C equals circle, centered at O, has a radius of R. We'll put a point on this circle, so we'll do P equals point on C to control the terminal ray of the angle. So now I've got a point P that lives on this circle, and I can adjust all of these things accordingly. P always stays on that circle. So now we'll actually go ahead and just create the initial ray and the terminal ray, but this time we're going to do things a little differently. What we're going to do, instead of creating rays, we're going to do something to represent rays, but visually looks a little different. So we'll do SC equals 1.4. This is a number that represents the scaling of our rays, and I'll show you what I mean by this once I create something. So do SC equals 1.4. And then we'll create the initial ray. We'll do init ray equals, and instead of using the ray command, we're going to use a vector that starts at O and extends to O plus SC times R, comma 0. So it's really a vector that starts at O and then goes to the right of O, SC times as large as the radius of this circle. So we'll hit enter, and we'll see what the SC is actually doing. Really, the SC scales or controls how long this initial ray vector is relative to the size of the circle. So right now, SC equals 1.4, which means that this vector is always 1.4 times as large as the radius of that circle. Similarly, we'll do term ray equals a vector that starts at O, and then we want it to extend to O plus SC times P minus O. Now there's some mathematics there, and it's probably worthwhile to take a second and look at this and realize why this command is doing what it's doing. But this command is going to create this vector that starts at O, goes through P, and the length of this vector is SC times as large as the radius of the circle. So real quick, I'm just going to clean this construction up by styling some things. Okay, so now what we're going to do is create the tick marks along the edge of this circle. So to do that, we'll do ticks equals sequence, and we want a sequence of segments. So we'll do segment. In each one of our segments, we'll do O plus R. Well, let's back up a little bit. Let's create the ticks along the edge of the circle. We'll create a variable to control the length of the ticks. So we'll do tick L equals 0.4, meaning that each tick will have a length of 0.4 units. Then what we'll do is do ticks equals, and we want this to be a sequence of segments, and each one of these segments will start at O plus R minus tick L divided by 2 times the point cosine of I sine of I, and then we'll want that to end at O plus R plus tick L divided by 2 times cosine of I sine of I. And we want this sequence to go from I equals 0 to I equals 6. Okay, so this is a lot, and again, there's some mathematics here that I'll let you guys dive into yourselves. But if I hit enter, what this is going to do is create these ticks along the edge of this circle. We'll make these black, and that looks pretty good. Okay, and now what we're going to do is get the angle formed by these two rays. So we'll do A equals angle. We'll start at O plus R comma 0. We'll use O as the center point, and then P will be our ending point. So again, A represents this angle formed here. We'll hide the label and make it blue. And now what we'll do is create the subtended arc formed by this angle. So we'll do subarc, and this time we're going to use a curve command for the subtended arc, and the x-coordinate should be x of O plus R times cosine of U. Y-coordinate should be y of O plus R times sine of U. U is our parameter variable. We'll start at 0 and end at A. Now I hope that this does what we want it to do. So if I select it, we're going to hide the label. We'll thicken it up so we can see it, and then we'll make this red. Now as we adjust the openness, that subtended arc length is being traced out. Okay, so now I believe the last thing we have to do is create the vectors that represent this output of sine and cosine. So we'll do sine vec equals, we'll do a vector that starts at x of p, which is the x-coordinate of p, and then we want the y-coordinate of the center, and then we want that to extend up to the point P. Similarly, we'll do cos vect, or cosine vect, equals vector that starts at 0. Nope, let's do y of p as the y-coordinate, and for the x-coordinate, we'll do x of O. And we want this vector to end at the point P. So we'll do vector from x of O, y of p, over to the point P. I'm going to style these up real quick. Okay, so now we have our applet. So we can drag the center of this circle. We can adjust the radius of this circle. We can adjust the openness of the angle. We have ticks along the edge to represent radian marks. We've got a subtended arc to represent the number of radians swept out by this angle's rays. And we've got these vectors that in some ways represent the output of cosine and sine, but we have to think a little bit more mathematically about that. For now, I'm going to leave it at this. You might have to pause the video and look at some of the commands that I entered and think about the mathematics behind them. Now, there's also a lot of ways you can pretty this up and add a lot of functionality to make this more useful than what it is right now. But I thought that this was a good example to show some of the ways in which we can use GeoGebra to portray some mathematical ideas.